Let me discuss this example. On a particular math test, the scores are normally distributed with a variance of 196 and a mean value of 140. First, let me define a random variable and note down the given information. Here we talk about math test scores. Therefore, we can define a random variable y as the math test scores. Now, given information: normally distributed, variance 196, mean 140. Here variance is given, but we need the standard deviation. How do we find the standard deviation? We know the standard deviation is the square root of the variance. Therefore, the standard deviation is 14. Now, let me write down this information in a mathematical notation. Here, y has a normal distribution, mean 140, and the standard deviation 14. Now, we know all the given information and go to the part A. What is the probability a randomly chosen student has a score at least 160? Let me convert this to a mathematical statement. At least 160 mean y greater than or equal 160. We need a probability of that. So probability P y greater than or equal 160. How do we find this probability? Here the random variable is y. Then we need to convert to the z. How do we convert to the z? Using y minus mu over sigma formula. Here y value is 160, mu is 140, and sigma is 14. Therefore, the corresponding z value of 160 is 1.43. Here you see I calculated z value for 3 decimal places, but I use with 3 decimal places. We need to round our z value into 3 decimal places before we continue. Right. Here now we have probability z greater than or equal 1.43. Can we use z table now? Not yet. Why? Here we have greater than or equal, but we need to make it less than or equal. How do we do that? Always we use 1 minus probability z less than or equal 1.43. Now check the two conditions. First one, z value. Yes, we do have. Next one, less than or equal. Yes, both conditions are satisfied. Therefore, go to the z table, find the corresponding probability of 1.43, that is 0.9236. Then subtract from 1, the answer is 0.0764. Therefore, probability of the score at least 160 is 0.0764. Go to the part B. When an instructor sets the grade cutoff points such that the top 15% of students receive an A, what should the cutoff scores be? Here, this problem asks you to find y value from a probability. Here we have top 15%. So first let me draw the density curve of this problem. Here the density curve is symmetric around 140 because mean is the 140. Then asking top 15%, that means the area right of P85. Actually, we need to find the y value that has 15% of the area from the right corner. Okay, why do I use P85? I will explain. We know first, can we use the z table to find this P85 directly? Not yet. Again, why? We need to find the left area, this area. How do we calculate this area? We know entire curve is 1, the area is 1, and the right side area, right corner area is 0.15. Subtract, it is 0.85. Now we know the area left of P85 is 0.85. Can we give me another name for this one? Yes, it is 85th percentile. 85th percentile. That's why I use P85 here. Now what do we need to do? As I mentioned before, we need to find the P85. Right, how do we find the P85? First, we know the left corner area. It is 0.8500. Go to the Z table. Check for the 0.8500 in the middle of the table. We cannot find that number, but we know the 0.8500 must be between these two numbers. Which one is the closest one? This is the closest one, 0.8508. Therefore, find the Z value for this. That is 1.04. Now we know the Z value from the table. Then we can find the Z value of P85 using the formula x minus mu over sigma. Here x is P85, mu is 140 and sigma is 14. So this is the Z value from the Z formula. Now we have two Z values. One is from the table, other one is from the formula. So these two must be the same. Therefore, make them equal and solve for P85. So answer is 154.56. Therefore, we can say that students who achieve at least 154.56 will receive an A in the course.